Hello Year 11. We're going to follow on from the last screencast where we learnt about experimental techniques to measure a rate of reaction, and we're going to go on to the practicals that we will need to know for our required practicals, and this is going to be the first one. I'm going to start with our retrieval practice. I want to know, what is a hypothesis? What is an independent variable? What is a control variable? And what three pieces of equipment do you need to draw a graph? So I want you to pause the video now and write down your answers on a piece of paper. Okay, hopefully you've done that now. Right, let's look at the answers. Right, a hypothesis is an idea that you can test. Now, in the AQA vocabulary for science, they define it as a proposal intended to explain certain facts or observations. What is an independent variable? An independent variable is the variable you change or select. What is a control variable? A control variable is the variable you keep the same because it would affect the dependent variable if you didn't do so. What three pieces of equipment do you need to draw a graph? Well, you need a pencil to draw the axes, the bars, the crosses, and the line of best fit. You need a ruler to draw any straight lines like the axes or your line of best fit if it's a straight line. And you need a pen to label the axes with the variables and the numbers. Okay, so our three success criteria today are: I will be able to formulate a hypothesis, which this required practical requires you to do. I will be able to identify all the variables in the investigation, and I will be able to use the results appropriately to come to a valid conclusion. Okay, so the required practical for the rate of reaction has two methods, as I said before. This is the first one, and the second one is going to be in a separate screencast. So we're going to use the colour change due to a precipitate, which we learnt about in the last screencast. This is the equation that we use. As you can see, we said before that we use sodium thiosulfate in hydrochloric acid. We are going to make sodium chloride as a product, water as a product, sulfur dioxide, which we mentioned in our risk assessment last time, and we're making sulfur here, which is the precipitate that is going to be measured. So how could we measure the rate of reaction? I want you to pause the video now and see if you can remember from the last screencast what we do. Okay, what we do is we record the time taken for a cross underneath the reaction to disappear. The reaction will turn cloudy as more and more sulfur is being made, and when we can't see the cross, we think that the reaction's finished. So therefore, that is the rate of reaction. Okay, normally we would have to do a hypothesis yourself at this point, but I'm going to guide you through it since we're not actually doing the practical. It would normally begin with, I predict that as the concentration of sodium thiosulfate increases or decreases, right, and then try to explain it. So you have to say what you think will happen. So the hypothesis that I'm going to put down now for you is, I predict that as the concentration of sodium thiosulfate increases, the time for the cross to disappear will decrease and the rate of reaction will increase because the time is getting smaller and the time's on the bottom of our equation. This is because there are more particles present in the volume, so there will be a greater number of successful collisions. Okay, so for our experiment, as we said, we're changing the concentration. So our independent variable is the concentration of sodium thiosulfate. Our dependent variable is the thing we measure. I'll give you a moment to think about that. Okay, what we're measuring is the time taken for the cross to disappear. And I want you to pause the video now and think about, from the screencast that you watched on factors that might affect the rate of reaction, what sort of things will we have to keep the same in order to make this a fair test? So pause the video now, write them down, and then come back in a minute. Okay, welcome back. Right, so the things we're going to have to keep the same are the temperature of the reaction, because that would make the reaction go at a different rate. The volume of sodium thiosulfate, because that will determine how many particles we've got. The volume of the acid, again, would have a different amount of acid would mean we might get a different amount of precipitate. We're going to keep the cross the same, because if you can imagine, if we have a really big black cross, it's going to take a lot longer to see it disappear than a little faint pencil cross. So we have to keep that the same for every concentration, and keep the same person looking at the cross, just to keep this and try and make this as valid as possible so they've got the same eyesight. Okay, so we've actually done both of those success criteria in one go. We're going to be looking at how we can use results appropriately to come to a valid conclusion. Okay, so this is the method to carry it out, and it might be advantageous for you to actually pause the video now and read it through to yourself. We're going to measure 10 centimeters cube of sodium thiosulfate solution and put it into a conical flask. We're going to measure 40 centimeters cubed of water and add the water to the conical flask again, so to dilute the sodium thiosulfate solution. We are going to be changing the concentration by dilution this time. Normally, you are used to having different bottles labelled with different concentrations of substances, but they're asking you in this particular practical to actually do it yourself. I'm going to explain it on the next slide. Okay, so we're making the weakest concentration there of 8 grams per decimeter cubed. We're going to put the conical flask on the black cross, measure 10 centimeters cubed of 2 molar hydrochloric acid, put the acid into the flask, and at the same time just swirl it before you start the stop clock, just to mix them. Look down the top of the flask and stop the clock when you can no longer see the cross. Record that time. Repeat it if you have time to make sure that your results are repeatable. And then what you're going to do is you're going to change the concentration after that. Okay, so pause the video now and read that through again. Okay, welcome back. Right, we're going to carry it out again, 1 to 7, changing the concentration. Now, this is quite difficult to actually understand just by reading it. We've got different amounts of sodium thiosulfate and different amounts of water. So what I decided to do was draw it for you. Okay, so the first time, the one we've just described, we've got 10 centimeters cubed of sodium thiosulfate and 40 of water. Okay, so 10 of sodium thiosulfate, 40 of water, making 50 centimeters cubed. That makes 8 grams per decimeter cubed. Okay, the next one, we've got 20 of sodium thiosulfate and 30 of water. So 20 of sodium thiosulfate, 30 of water, and we've still got 50 because we're keeping that as one of our variables that we are keeping the same. Then we're going to use 30 of sodium thiosulfate and 20 of water, making 24 grams per decimeter cubed. Then we're going to use 40 of sodium thiosulfate and 10 of water to make 32 grams per decimeter cubed. And then finally, we're not adding water at all. We're just using 50 centimeters cubed of sodium thiosulfate. Okay, so what I recommend you do, because I haven't got time to play them here, is pause the video, copy these links and watch the experimental techniques on YouTube. So you'll get an idea of what we've been describing. Okay, welcome back. Right. Another thing you have to do for an experiment is to do a risk assessment. Now, normally you would be given what's called HAS cards for any chemicals. Teachers normally do this for you, but you have to be able to do a risk assessment. So I've written down the equipment and chemical and the hazard it causes. So hydrochloric acid is irritant. Okay, so it irritates your eyes and skin. Sulfur dioxide is made, and that also can cause breathing difficulties. So I want you to pause the video and tell me what the risks are to people and how you would actually stop them from hurting people. So pause the video now. Okay, so acid is irritant. Now these can be in either order, but the acid can get into your eyes. So this is a bigger risk, really, and it can damage them. It can really hurt them. So how would you minimize that risk? You would wear safety glasses. However, if you did get it into your eyes, you would seek medical help very quickly, like your technician or teacher, and they would wash it out of your eyes. Okay, the acid is an irritant. It also will irritate skin. So it'll make it sore or red. How do you minimize that risk? Well, you quickly and calmly wash the acid off your skin. You don't have to panic because it is only irritant, but you just wash it off your skin or wash it off your clothes if you get it on. Okay, the next hazard is the sulfur dioxide fumes causing breathing difficulties. So the risk is, I mean, it can affect everybody, but it would particularly affect people with asthma. And the fumes will cause breathing difficulties. So trying to think of how we could minimize that. Well, we're going to open all the windows and keep the room well ventilated and dispose of the leftover sodium thiosulfate and hydrochloric acid in a fume cupboard, or at least in a sink near a window, and don't be doing it all over the room. Okay, so here's a set of results obtained by a technician. What I want us to do is pause the video now and calculate the mean for each concentration. So I'll give you a few moments for that. Pause the video now. Okay, so what we do when we're doing a mean is we will take all the different trials that we have done and add them all up together and divide by the number that we're going to include. So if there are any that you don't want to include because they're anomalous results, we won't include them and we would divide by 2 in that case. So the first one, 137, 138 and 136, very close to each other. So we're going to divide by 3 and the mean is 137. The next one, 76, 75, 77, again, very close together. Add them up, divide by 3, you get 76. The next one, again, really close together. No variation around the mean. Okay, so the answer is 46.3. But we've got a problem here because all our data is got no decimal points. So we need to put our mean to the same level of resolution. So it's not 46.3, it's 46. Okay, in the next 3, we've got 37, 45 and 37. So what we need to do is ignore the 45 because it's so far different from the others, right? It's nearly 10 seconds more. So we're going to just add up the first trial and the third trial and divide by 2, and it's 37. Okay, and then again in the last one, very close together, so we can use them all together. 28, 26 and 27, and we get 26.7. Now we should know what we need to do now. We can't have it as a decimal point, right? So we are going to round it up to the next whole number because it's over 0.5. So it's 27. Now, if you have graph paper at home, you would be able to plot a graph of those results. Remember to check for anomalous points when you're drawing out your line of best fit, but the curve should look like that. Okay, from that, you should be able to now draw a valid conclusion. So using your results and graph, describe what has happened to the rate of reaction when you increase the concentration. This should be an answer to your hypothesis. So it should start with either my hypothesis was correct or my hypothesis was incorrect. Then you go on to describe what you found out. As I increase the concentration of sodium thiosulfate, say what happens to the time, and then try to explain your results in terms of collision theory. So I want you to pause the video now and try and write yourself a conclusion and then come back in a minute. Hopefully you got something that looks like this. My hypothesis was correct. As the concentration of sodium thiosulfate increased, the rate of reaction also increased. This is because increasing the concentration means that there are more particles present in the volume. So there will be a greater number of successful collisions. Okay, sometimes in an exam, they will also give you an alternative method and ask you to compare. So in this case, we're looking at a light being shone through our cloudy liquid, a light sensor connected to a data logger and a computer. And as the liquid goes more and more cloudy, less light's going to come through and it will be picked up by our light sensor. So we're going to compare and say which one would be the more accurate method. So when you are comparing, you have to use what I call words. So it is longer, shorter, more accurate, less accurate. Something like that. So I want you to pause the video now and compare the two methods. Right. Okay. So hopefully you've said something like this. In our experiment we looked at, the result relied on judgment and eyesight. We would all get different times for each concentration, but we'd all get the same shaped graph, so our results are reproducible. Using the data logger, light and light sensor would not be dependent on judgment, so would always be consistent. It would be more consistent. This means that they would give us the same result for each concentration, i.e. the true value, and that's what we mean by accurate. So it would be more accurate. Okay, so we have achieved our 3 success criteria. Thank you for joining me today, and hopefully you'll join me for the next required practical to finish off what we need to know about required practicals in rate of reaction.